It takes a little bit. Hi, I'm Bill Oakes. I'm the director of the Epics program that's headquartered at Purdue University, and I want to give you an overview of the course and curriculum that we use in Epics. Now, one of the first things that I have to say is Epics looks different at every institution where it's implemented. So I'm going to use some examples that have been successful at Purdue, where we teach, and other places, but you need to feel the freedom to adapt it to your own institution. The graphic behind me kind of shows that we've got curriculum pieces that can provide some guidelines and some tools, but it has to be adapted based on your own culture and your own community. When I think about that, I think about the Purdue Epics characteristics, and I want to stop with a disclaimer here. The disclaimer is at Purdue, we started in 1995. So we've been doing this for quite a while. Epics has grown to a very large course and a structure. And so when I talk about some of the examples, I don't want you to think that you have to get to where we are and have to implement all the characteristics right now. Again, part of adapting to your own culture, as I showed back here, is figuring out where it's appropriate to start. But when I look at the Purdue characteristics, we are what we call engineering or computing-based design. We are multidisciplinary. We're very multidisciplinary. We had about 70 different majors participate. In a typical year, we're between 70 and 80% engineers, but we intentionally talk about engineering-based design because all of our designs involve technology in some way. And they are all designed, but we don't want to scare away students from business, liberal arts, and other majors because we need them for the design. We have long-term partnerships. That is one of the characteristics and one of the core values of Epics. We have some of our original partners and several of our partners back from the 1990s that are still with us. A benefit of that model for faculty is you don't have to go recreate and find projects. This year we had about 90 projects, a little less than that, starting in the fall, and I believe that there were about half a dozen projects that we as administrators were involved with. So we had over 80 projects that continued into this year without our involvement, just based on the partnerships and with the student engagement. At Purdue, we are vertically integrated, which means we have first year, second year, third year, fourth year students. That we mix. They take courses and they're all mixed together on the teams. Those first year, second year, third year, fourth year students, again, come from 70 different majors. And our curriculum is set up so we have an extended design experience. Most of our students take Epics for at least 2 semesters. Many of them take it for 2, 3, and sometimes even 4 years. The outcomes that we have for our Purdue Epics class are shown behind, and these outcomes come from the ABET, our accreditation criteria. The accreditation criteria for engineering, with one exception, you see, we've substituted the word engineering and technical for in your discipline. So when a student comes from business, they're assessed in our program, and the learning is based on how they apply their knowledge from business or management to the design of the community-based projects. Understanding of design, identification of new knowledge, etc. So these outcomes are the learning outcomes for all the students. Now, I'll emphasize this, but I want to say it explicitly. In our course, the learning takes place based on the project work. And we don't have a lecture or theoretical set. We have a few lectures to introduce students to our concepts. But these outcomes actually derive from the project work and the learning and the reflection and discussions that we have within the project work. Our course goals that we talk at Purdue, we talk that students will experience multidisciplinary design. And by the way, in our accreditation criteria, multidisciplinary teaming is explicitly listed. Often we don't, in the US, we don't think in terms of that in a classroom is within and outside of engineering, but that's the intent for industry, and that's the intent that we have. Professional preparation. The things that we do and the practices that we have are modeled after getting students ready for what they're going to do after they graduate, prepare them to be professionals. And with service learning, we are providing a service to the community, and the students are learning valuable things that are going to make them effective professionals. Our course structure is set up. Now again, this is one model, and this is what we use at Purdue, and there are other kind of models, but for us, at Purdue, we have a 2-hour lab where the students all meet together, and that is essentially, when you think about it, as the course. Me as an instructor, and we call the instructors advisors on our campus. That's the time when I have blocked off to meet with the students, and all students are there. Now, as any course, we expect students to work outside of class, kind of their homework. So they don't have homework assignments, they need to continue to work on the projects. On our campus, we have students to register for 1 or 2 credits, and they're on the same team. And the way we distinguish those is the outside of work, the outside of class part. Is a 2-credit student would still go to the lab just like the 1-credit student, but they're going to do twice as much work outside of lab in between classes. And then we have a set of what we call learning activities. They can be lectures, what we call skill sessions, where students may learn soldering, teamwork skills, learn some software packages, or workshops where we do something more extensively, or we could have industry people come in and talk to them. They're required to have 5 of these if they're 1-credit students, and 10 of them if they're 2-credit students. I try to translate these learning activities into what I need to do as a professional engineer to keep my license updated in professional development hours. Now, some models that we've kind of broken, academic models that we've had to break, there are a number of them, and I want to talk about the time scale issues, because what we tend to think about is a student comes into your class, they don't know anything at the end of class, that they're perfectly informed, fully informed, able to go. If I do a project in the class, it starts at the beginning and it goes to the end, and magically it ends right when the semester ends. And that's great if everything goes as planned. When we're doing community projects, there are things that are going to come up that we can't plan for. And the thing that happens often is I've got students that are learning, and I've got projects. What happens if that project's not finished? And what we have in our structure is we allow students to come into our class at different semesters. Most students take our class for more than 1 semester or academic period. And what that does is it allows us to decouple the semester timeline, academic year, from the project timeline. So projects can begin and end at any point in the semester. The graphic here shows a project that was started by a student. It ends in the middle of this semester that's carried on with the second set of students. And so during the semester, the next project begins. And so at whatever time that you're watching this, we have projects at Purdue that are ending and starting during the semester. A key part of that is 2 key parts. It enhances the learning from the students because they get to see the entire cycle and they get to work on it until it's finished. A big part is this bullet down here is the community receives the support that they need. If the semester ends and the project's not finished, we can't just give it to the community and say, wow, you got to go finish it yourself. They don't have the expertise. And so this allows us to continue to work on a project until it's finished so the community receives what they needed. Now, to manage this, and you may say, well, if the project's not finished, how do I grade them? Because in a traditional project, they get the big grade based on the fact that they finished the project. Well, what we do is every semester, we work with the students to do a timeline, an example shown here for the semester. So whatever our students and myself have agreed to be done by the end of the semester, that's their grading scale. That's the expectation that they've got. And the timeline here, you notice that it's grayed in. So this shows things that they finished, and then other things that they haven't. So each week when we go through, we look at their timeline and look at their progress. Are they ahead? Are they behind? And they can help manage. This gives them great project management experience. I have to laugh because I have students that will ask who in their right mind can figure out what we're going to do for the year or the semester before we've done it. And how do we know how much it's going to cost? How can we do a budget and timeline? And students will question that. until they graduate and they get their first job and they come back and they say, Professor Oakes, I'm so sorry, I realized the answer to that question is that every project starts with a project plan and a budget. And that's what we're trying to train the students for, is to be leaders once they leave. Now, when I think about the semester plan, the other timeline was related to the project, but each semester we break the semester into 3 different kind of sections. And the first part of the semester is always planning, because we have new students coming in, they have to be adapted, and we're developing the plan. So some project work happens up at the beginning, but we're also doing some planning. Now the students get frustrated often at the beginning of the semester because they want to be building. That's what happens in the middle of the semester. Toward the end of the semester, we need to be looking, either we think the project's going to be finished, but if it's not going to be finished, we have to be documenting so that we can leave the next semester with enough information so they can pick up where we're at. Now, one of the things that we found is we do not allow students to deliver a project right at the end of the semester. And that's just because the community has asked us not to do that. Because too often a project is delivered and then something goes wrong and the students are gone. So we actually back it up where the students have ideally 4 weeks, but never less than 2 weeks, where they're still on campus when the project is delivered so they can take care of things. Sometimes that does mean that on our campus we'll delay delivery to the following semester so the students are there. And the community has said that's actually preferable. Now with these project timelines and all this, what we found is students are still used to, is there a list of things that I have to turn in? And so another document we provide students, and this is an example from a little bit ago, is here's what I have to turn in. So we have a list of deliverables for the students, like assignments, but then we also have the things that they have to do relative to the project. In Epics, we teach what is called a human-centered design approach, and the human-centered means that we put people in the middle, stakeholders. Who are people who are going to be impacted by the design? Human-centered design is one of the things that is being talked about as a key element in engineering education. Is how do we make students globally competitive, is they have to understand the human-centered design, how people are actually going to use it. And Epics and the community-based projects becomes a wonderful environment for them to apply those skills. Because the community often doesn't know what they need. And human-centered design principles include an early focus on users. So our students have to understand the community. Designing with the users. So engaging them in the process. Measurement and evaluation and iterations through the process. We have to understand who the stakeholders are, what information that they need, what are effective ways to get that information. And I'll talk about one of the things that we teach is prototyping, so the students can build something to get some information. And how are we going to measure if the goals are met? The community projects are great, but often our community doesn't know what they need until they see it. And then we have to understand which of the stakeholders are involved in the process. Now, I talked about prototyping, and as an engineer, when I think about a prototype, I think of something that's working that essentially looks just like the finished product. And that can be a type of prototype. But we also want to do, as part of the iteration, can we do intermediate prototypes that are fast to do where we can get information back? IDEO is a internationally recognized design firm, and one of the examples for them is they were developing a surgical device to do nasal surgery. And they were hired by the company, and this is actually the finished product. But early on, they contacted the company that was contracting them, and they said, we have an initial prototype, and what they actually showed them, sorry, don't know what button I hit just there. This was actually the prototype. Now, I will have to caution, if you use these slides or use this video, you're going to have to explain to students what the black thing is. That's actually a film canister. So when I talk to my students and I mention film, I have to explain what film is to them. but it's a clothespin, film canister, and a marker. And for this case, the state of the art, all the existing devices had the handle in line with the actual device. And what the design team said is we think that we need a 90 degree, which is what they went to. But they did this prototype so they could get feedback from some of their stakeholders on, will this actually work? And once they figured out that concept, it drove the final design. And by the way, the entire industry went to the 90 degree after they did that. These kinds of prototypes are great for soliciting information over the community. It's one of the things that we teach the students. And prototypes could include visual representation. If I'm doing software, I might do storyboards on paper. I can do drawings. I can do a functional mock-up. But getting students to do prototypes to get information that then feeds back into the design is important, not only to get the community project correct, but for their design education. Now, a little bit about how we're structured. We have our teams, our classes are student run. So at the top here, we show a project manager. And that project manager is the team leader, that they're in charge of the class. When they come in, they're actually running a team. Now, power for this is students that then go and they interview and they go into industry, they've actually led a design team. Not just a class and pretended, they've actually led a design team. For each project, then, we have design leaders. Now, the idea here is that project leaders worried about those timelines. The design leader has primary responsibility to make sure the design is good, perfected, or good enough for the community. In a company, there's a little tension between the project people that want it done and the designers that want to continue to iterate until it's perfect. And we try to set up that tension or just students that have different voices so that we can determine when is a project ready. I will say there's a mistake that we can fall into is trying to get the design so perfect that the community never gets it. And often it's better to deliver version 1.0 to the community than work on version 2.0 and deliver that so that they've been able to use the first version. This shows a typical class would have me as a faculty advisor or somebody else truly advising. So I will sit back and add my guidance when needed. Often students need to experience something. The visual that I use often as an advisor is if I know students are headed for a cliff or for a mistake. Often, some students, you can tell them the cliff is in the distance and they believe you. Others have to get right up so that they see it. So sometimes students need to run through some of their ideas. Other times that you can say, and that's part of the art of teaching. There's not one answer to that. But I try to stay out of the way if things are going well. We have other roles too. We have a webmaster for every team. A website's great to communicate. We have a community liaison. Our community partners don't want every single person texting or emailing them. They want a single point of contact. And then we have a financial officer. On our campus, we have a certain amount of money that teams can pull from, and the financial officer is the one that manages that budget. We have students that put together design documentation, so there needs to be something related to the design. We have a server system. We actually use Microsoft SharePoint for students to upload their documents. These documents are ones that are going to stay with the projects. So if a project is delivered and 3, 4, 10 years later it needs some service, there's documentation that the students can read. On a semester basis, it's going to have their project plan. We run students through design reviews twice a semester, and the feedback from that is also in that. Part of the learning that goes into this is the students need to, part of the learning needs to be made explicit to the students. We may believe that students are learning certain things, but if it's not made explicit to them, a great learning opportunity can go right past them. So we have the students write reflections each week on how the project's doing. What I tell the students is I want to see your thinking. I want evidence of your thinking. And so one of the things they're graded on is their critical thinking. And it can be the decisions they have to make on a project, what they think needs to be done next, how the team is working, about the community project, a number of different things, but they need to write on those. We will have students do that weekly. We also have students do a final reflection at the end of the semester. This is a way to get them to synthesize what's happened in the semester. It's a wonderful way to collect data from the students to get a snapshot of what's going on. That's kind of a high level of how we run the class, some of the key points. There's more information on our website, and there's more information on some of the other modules that you're welcome to see. Thank you.